This will be an introduction to Numpy arrays. So everything here is going to be incredibly basic. I won't actually be explaining how every single thing works, but like if you just see my code, I think you're going to be able to understand it. So the first question is very simple. It says create a Numpy array called ages having the structure and content of the following table. So we can just say ages is equal to numpy, well, np dot array. Then we just use square brackets. Then we say 7, 3, 2. Then another comma in between. And we say 852, 852. Then 1, 9, 12. 1, 9, 12. Well, then, well, okay. All we have to do after is just print ages and see if we actually did it correct, if it looks the same. What mistake have I done here? Oh, it's because I forgot to add the brackets in the outer layer. Yes. So if you see now, it's exactly the same in what they actually wanted us to do. So yeah, that's correct. We can go to question 2. If you're actually saying like, why does it work like this? Honestly, like this is just a built-in function. Numpy is a library, so it's even more built-in functions. So it actually doesn't have a reason. I bet it does, but I think it's a bit redundant to learn these type of things. You can just accept it as a fact and yeah, just move on. Select the second column and find the highest age. Print the result. Okay, so to select the second column, let's print now to selectively pick a row, we have to do like ages, then we have to select the second column. So the second column is going to be all of the rows, and second column is going to be this. So let's actually see if this is correct, if it's the second column. It is the second column. So then to find, okay, before we actually continue, I'll explain what this does. So the first element within the square brackets is actually for rows, and this means all of them, like for all of the rows, and then the first column. So think it like that. If this means for all of the rows, right? So it checks out all of the rows, but then specifically the first column, so this one, then 3, 5, 9. If it was 0, if it was 0, 0, so check this out. I think it would give us one item. Exactly. It would give us the first item because it's, so the first row, so the 0th row, and the 0th column, and it's, yeah, it's first item. So exactly, we get 7. But if it was, let's say, 1 to 2, I don't know if this is going to change anything. It gives us 8. So this actually gives us the first column, and then the 0th, the first row, and then the 0th column, which is the number corresponding to 8. But anyways, so we need all of the rows and the second column. Let's double check again. 592. Then we can just print max of what we had here. Then it's actually just, this is again a built-in function. It's going to return the maximum number here, which is going to be 9, which is correct. Exactly. It says it here too. Let's move on to question number 3. A year later, everyone is a year older. Add 1 to all values and print the result. The result should be saved as new ages numpy array and printed. Okay. New underscore ages is equal to, well, it was ages plus 1, I would say, then print new ages. Well, let's see how this goes. So as you can see, it automatically adds 1, but I'm pretty sure, hold on, I'm gonna check my notes before I teach you something else. There's actually another way to do it if you know the dimensions of your NumPy array. Yes. For example, if you try to instead add np.full built-in, and then what is this? A 3x3, so a 3x3 matrix, and the full ones. I think we have an extra bracket, but it should be okay. It also gives the same answer, as you can see. 843. So this is basically a built-in function. It basically says return a full, I'll start like this. Return a NumPy matrix that is 3x3 and it's full of ones. That's how you can understand it. If I said 7, it's going to be full of 7s. So it's actually going to add 7s. But yeah, I guess this is less easier than this one. You can just add 1, and Python is going to treat all of them separately and just add 1 individually. And yeah, you're going to get the same result. Hold on. It ends with 13. Okay. I thought it ended with 12, which got me confused, but I just misread. Alright, let's move to question 4. You wish to filter the new ages NumPy array and remove any age below 6. Create a function ageFilter that takes a number x as input and checks whether x is less than 6. If it is, the function returns 0. If it is not, then it returns x. Okay, so this question is trying to teach us another concept, so it's actually quite helpful. So this function is, as of now, independent of NumPy arrays. All you have to do is, if x smaller than 6, return 0, or else if x greater or equal to 6, return x. Yeah, you could have just used else as well. That also works. So we have to do this. You need to convert it into a NumPy function. So in order for us to use this function in a NumPy array, we need to convert it to a NumPy function. And Python is actually helping us a lot here. All we have to do, well, based on the exercise, they already give us the answer here. Convert the function into NumPy function. So this actually, np.vectorize already converts this function to NumPy format. So you don't actually have to work too hard to convert your function that works for single numbers, sorry. And you can just use this so that it works for NumPys now. Okay. Now call this function to filter your new ages NumPy array. Save the results as filtered ages NumPy array and print. Okay. Is equal to age filter np, and within our function, because this is a function now, it should have this NumPy, which is not new ages, but ages, I think. Does it say if it should be new ages? Ages. Then print filtered ages. So as you can see, our original ages group, it's here. hold on, they actually mean ages, though updated. Or is it new ages? Yeah. Alright, so just our function, because we use the vectorized built-in function, now what we do is our code here basically makes it so that Python realizes this and it iterates over all of the values within our NumPy array and checks whether it fulfills this condition, which is whether that specific x that it's currently iterating over is smaller than 6 or not. So that's what it's doing. And then if it is smaller than 6, it's returning 0. If not, it returns x. So that's what's happening here. Question 5. Question 5 is more so an experiment, but it's quite helpful as well. Now try out a different function without using a function. Check it out. Okay. It's supposed to be age filter A, I'm pretty sure. So as you can see, if I scroll up, what we have here as the new code returns this result, and it's practically the same. It is the same output in the end, because what it does, it's basically taking our new ages NumPy function and then it's saying whether it's bigger than or equal to 6. Then if it is, just put it to another NumPy array, which Python automatically understands that, and call it a new variable, right? Hold on. Sorry, I actually printed the wrong thing, sorry. I mean, it's going to be the same result anyways. Well, apparently it's not. That's my bad. But that is actually the purpose of this question anyways, so that's okay. This is supposed to be an experiment function. Well, because what happens, can you think of why? Exactly, so it's trying to make you think like, why is this happening? Which I tried to do previously, but I just mistyped, sorry. So here what's happening is it checks a condition, and if it fulfills the condition, it returns true. The condition is whether the number is bigger than 6, which it is true for the first number because it is 8, then false because it's smaller than 6, and so on and so forth. Okay, what happens next? So it's again the exact same type of question, but this time it's a bit different. Yeah, let's not do the same mistake. Okay. Right. And this is going to be our age filter, because what happens here is like, for example, let's print age filter as well. It's basically the same thing where we had the true and falses. So the reason why we suddenly get numbers now is because obviously in computing, true means 1 and false means 0. So what we end up having is true, which actually has a value of 1. It's 1 times the value of new ages, which is going to be 8, so it's going to return 8. And it's going to be false times the new ages, which is going to be 0 times whatever the value we had. But 0 times any value gives you 0. So that's why we get 0. And this process just repeats for all of the values. It just iterates over. And at the end we get this. So this was an introduction to NumPy arrays. I hope it was helpful, and I hope you understood it. I'll be recording a part 2 soon. So yeah, thanks for watching.